Okay, so in this video we're going to look at graphing exponential functions now, which are similar to logarithms. If you're ever confused about which graph is which, I would suggest you plug in numbers to try and figure out kind of the shape of the graph. But let's just review what the graph of 2 to the x looks like. So 2 to the x, if I plug in, can we see this? Yeah, okay. We plug in some numbers for x and y. So this is for the graph 2 to the x. Okay. When I plug in 0 for x, what do I get? Well, I replace x with 0, so we get 2 to the 0 is 1. So we're up here at 1 when we're at 0. Then at 2, when I plug in 1, I get 2. Okay, then at 2, I get 4. Okay, so 1, 2, 3, 4. Okay. Now notice these are kind of the same numbers that were showing up on the last one for the logarithm, right? Which makes sense because log base 2 is the inverse function of 2 to the x, so it switches around the x's and the y's here, but the numbers are going to seem very similar to each other. If we go to -1, we plug in -1, we get 2 to the -1. A negative exponent means we divide, so we get 1/2. So we're going to be here at 1/2, and we're going to be something like that. Okay? So that's our exponential function, 2 to the x there. Okay? And so what we're going to be doing now is graphing a transformed version of that. Let's look at 2 to the x plus 2 and then -1. So the plus 2 up with the x means I'm going to be moving to the left, right? It does the opposite of what we might think it would because it's next to the x. Then -1 on the outside is going to move us to, down 1, right? So we're going to go 2 to the left and down 1. Okay, so 2 left and down 1. That's where our real point is. 2 left, down 1. 2 left, down 1. So it's going to be like this. So this is our graph of G. Okay, so we moved it 2 to the left and down 1. Okay. Okay, so now let's find the y-intercept of our function, which again just happens when you plug in x equals 0. So g of 0 is, well, it's 2 to the 0 plus 2 minus 1, right? So we get 2 squared is 4, minus 1 is 3. So again, the y-intercept here is 0, 3. Okay. Okay, and then the asymptote of g is this line right here. Normally our exponentials have a horizontal asymptote at y equals 0, but when they're shifted, right, you can move the asymptote around. So this is the new asymptote, the thing that it's getting close to. We took the y equals 0 line and we moved it down 1, so it would be y is -1. And then we've already got our graph there. So this would be our answer here. So hopefully that helps you just remember how we graph exponential functions This is very important. I guess I will see you in the next video.